the folded X-beam. So I'm going to scan this baby real slow for you guys, so you can stop and get any information you need out of it. Here's all the formulas here. Tuning and adjusting. And here is some dimensions. There's full size beam and the minimum size beam. And here is some more tuning. Right? And then here's the X-beam. So this thing's done on the flat plane. Just a board. I have mine cut in half. And I have a hinge on here and here, so I can fold it in half in the back of the truck. Now it's supposed to have a string all the way around, and these are supposed to be tied up horizontally. I leave mine hang vertically off the ends. So I'm using 1/2 inch by 1/2 inch, 1/8 inch thick angled aluminum with 12 gauge high strand wire hanging off the ends. You can see the back of a little radio right there I used for the PL259 right there. And I use that little bit of radio to hook my connector onto. I run a short piece of 50 ohm through the board and hook it to the other side. And so the back two there, you have the two driven elements hooked to each side of the coax, 50 ohm straight feed, and you can put a balun on there. And then two directors, they have a small wire that's connecting them. All my wires, I soldered the ends of the wires, and the 90-degree angle stuff helped in ease of putting the screws in. So we'll get that up here on a little bigger piece of paper here. The full-size X-beam, full length of the driven element and the director element, and this is all calculated at 27,400. The driven element here, the tails, the wire that hangs off the tails, this is the formula for it, over frequency and feet, right? The arms, all four arms are equal, 195 over the frequency, and so that's the math of it there. And then there's a minimum size beam. So you're using this formula for the length of the arms and longer tails. Okay, but overall, it will come out. If you do the math, it's this thing here, it's just has shorter arms and longer wires, longer tails on it. And of course, it's all built on a 1/2 inch aluminum tubing with 19 gauge wire on a 200:1 build ratio. Like I said, I went a little bit different. I actually used a material like this, some 90-degree 1/2 inch material, and a 12 gauge high strand wire hanging off the end, so more surface area the better. The ARRL handbook, the 1991, that's the one I just showed you there, section 33, page 12, the folded X-beam, 27 to 40 megahertz to 40 meters to 10 meters. Okay, and then my next source is the folded X-beam on the web at tantop.org, modeling and understanding small beams. It gives modeling for front to back gain, side SWR, etc. The beam width of this bad boy is about 62, 68 degrees. And the angle of takeoff, pretty important thing. About 24 degrees at 20 feet, 14 degrees at 40 feet. Like most beams, the higher you get up, the flatter they are. It's got a 7-foot 2-inch turning radius. And it runs about 6 dB and maybe a little more depending on tune it. Okay, for instance, I wrote 29 here because that's what the math is. It's supposed to keep these 6 inches difference on each end, so that's a foot difference between the entire the driven and the director. It's supposed to maintain that. So in this stuff on the folded X-beam here in the web, they lengthen and shorten the wires to get different gain and front to back ratio out of it. So I have been running 27 inches instead of 29 on mine, and I just put 29s on it and it didn't. And I'll put up another short video of this thing on a antenna tuner of the matching stuff I had with it over the truck there. And so yeah, there's a jumper. I got a 12 gauge jumper on my director between the two elements, and I soldered the ends of all my wires. So theoretically this bad boy is supposed to be 22 and 21 foot. Now in the real world, I like the upper side of the band. You know, I like to talk around the world, so this is my tuning for that. My driven element total length is 20 feet and my director is 19. So I got 7 foot 1 3/8, 85 inches. There's the math per element. So it is I'm maintaining the ratio, but in the reality versus theoretically, it's going to be a smaller antenna. And then on the modeling on this thing, this is a 2-element Yagi, and this is the X-beam, and it has an odd-shaped lobe on the back of it because it's an X. It's not round. It can, if you tune it right, you can get kind of a 2 round balls out of it to get the most gain. The best SWR looks like just a sack here. The best gain is got a couple actual lobes on it. And I can turn this baby over down to the southwest there towards Australia and pretty much tune out the east coast at times. So we had some good DX here running, but it's starting to die off and it's getting kind of quiet. A CQDX, the Volcano 55 Mount Shasta, we're looking.
Area 55 Volcano 612 with a wire.
Yeah, very good, Rick. 612 down under. I'm doing a video on the folded X-beam, making you a star there, QSL.
QSL, good on you, Jesse. You only had a friend. I just come down to 37 the other day, and I put me call in there.
Yeah, very good, mate. Very good. I've got about a 3x5 on you. Very nice audio. How about some numbers from your end, QSL?
You're doing the same to me there, Jesse. That's why I can hear you. That's why I'm talking to you. Hey, 45 Volcano 612 down under.
Yeah, very good. That's Swamp Rat, Newcastle, down under. Thank you, Rick, for the report. Look for my video on Volcano 55 Mount Shasta. I'm going to post it tonight. So thank you for the report, my friend. 7.3. So working that folded X-beam at 7,700 feet level on the side of Mount Shasta, 50 miles from the Oregon border. We're waving.
Catch you later there, Jesse. Have a good one, brother. Beers and cheers from down under.
Cheers and beers, mate. 7.3s.
73.
All right, people. Well, there you go. That bad boy does work. All right. The ugly face behind the mic. 7.3s, people. The old ski bowl's just up there a little bit above us. And like I said, I'm at 7,700 foot just about. And Mount Shasta is 14,162 feet high. So got about another 7,000 feet of mountain hanging up there. And we're kicking back at Timberline. 7.3s, my friends. Bump, bump.